Hello, today I'll be going through my Emath 3 assignment video about Euler's method. Firstly, the Euler method. It is a numerical method used to estimate the solution of differential equation. This method works by using the rate of change at a known point to predict the value at the next point by taking small steps along the curve. An example is shown on the left side. So how do we get the formula? By finding the gradient rise over run, which equals to y1 minus y0 over x1 minus x0. We can substitute that with m. And m also equals to dy dx, which also equals to the function of x0 and y0. Since we know that, we can equate the gradient of y1 minus y0 over x1 minus x0 equals to the function of x0 and y0. We also know that x1 minus x0 equals to h. And multiplying h on both sides, we get the second last formula over here. And since we want to find y1, we add y0 on both sides to get the final Euler's equation. And on the right side, it is the graph of the equation that we are solving, which is y equals to square root of 2x cubed over 3 plus 2x plus 1. So this is the question that we need to solve. Dy over dx equals to x squared plus 1 over y, where y is greater than 0, given the initial value y0 equals to 1. Find the approximate value of y1. So this is the formula that we're going to use, where yn is the value of the next y to be calculated using the formula. Yn minus 1 is the previous y value, h is the step size, and lastly, the function of the previous x and y value is function bracket xn minus 1, yn minus 1. So x equals 0, y equals 1, and the step size we're using is h equals 0.1. A smaller step size h does lead to a more accurate result because the assumption of a constant slope over the step becomes more valid. However, it also increases the time computation to calculate all the values. So I've chosen a step size of 0.1 to satisfy both areas. Moving on to the table, the leftmost column n shows the step number, and x shows the step size at that particular step number. And the light green column in the middle shows the differentiated value of the equation by substituting in the previous x and y value shown with the blue and red boxes. This formula is used for the following rows also. As for the y value, we substitute the values into the equation. So taking the y from the previous step number, adding h, which is 0.1, multiplying that with the function of the previous x and y to get the predicted y value. This picture shows my steps to solving the equation using the calculation. Take note, the second last step, y equals plus minus square root 11 over 3. I only consider the positive value since the questions say y is greater than 0. And the value I got is 1.915 to 3 decimal places. And the y value at x equals 1 using the Euler's method is 1.911. Thus, the approximation of error is 0.004. This tells me that the predicted value of y is reliable and the step size used is good. That will be all for my presentation. Thank you.